Okay, so for this lab, the purpose first to verify central limit theorem. We just explore the sampling distribution, okay? And also to learn some simulation skills in Excel and Minitab. Yeah, we already know how to do it in Minitab. We just to repeat again. So suppose that the probability distribution for a population is a uniform distribution. So what does that mean? It's uniform from 0 to 100. So this random variable could be any value between 0 and 100. You random pick one from the population, the chance, the probability is the same. You pick 0 or 1 until 100. So every the value will have the same equal probability. So this is called uniform distribution. The uniform distribution, so this is a continuous random variable because it could be 0, 0.1, 0.11, okay, until 100. So theoretically, we can calculate the mean is the average. Average mean is 50. The standard deviation sigma, we can calculate based on the formula. So we know this is mu is the parameter. Okay, so that's the population mean. We also know sigma, that's the population standard deviation. Now we like to see how about the sample. Okay, so we will generate sample 1,000 random sample. Sample size is 35. So every time I pick up 35 numbers from this population. So how can we do that? So first we see this is the uniform, just uniform distribution. The sample size 35. Okay. So for example, how we do that? Just go from here. Just generate a random sample. So there is a formula in Excel. That means you generate a random number between 0 and 1. Okay. Since we have this one, our population is a random variable from 0 to 100. I just multiply 100. That means it will give me a number from 0 to 100, just a random number. Okay. So we have 1 until 35. So how about do this? Instead, I just data 1. What data 1? Data value 1. And value 2, because we want 35, right? So this is 17. I can keep track. This one to 35. So certainly we can simulate this in Minitab. So we try to learn another way to do simulation. Okay. So this is the sample. Okay. Sample ID. Okay. So the first sample, I pick up 35 values, which are from the same distribution, same population, which is follow uniform distribution. So any number between 0 and 100. So this is the first one. Next, I want to select 1,000 of them. And then I like to know the distribution of the statistic. Okay. So here, we will have a statistic. Statistic is the mean, okay, sample mean. just the average, right? In here, just the average from this one, and shift, you can go down to 35 of them. Okay. So we have the sample mean. So this sample mean we also call statistic, right? We like to see, is there any relationship between this sample mean and the true population mean? We already know mu equal to 50. So you see, first one, the average of this 35 value, that's 48. It's quite close to 50. And then what we are going to do, we want 1,000. Just to keep drag down, it's not that many. So, okay, it's around here. It's 1,000, should be 1,000. Okay. So sample ID 1,000. And then we can do, let me see, if I just double click, it will automatically fill the data until the end of my my index. Okay, so I can do the same thing. So we can speed up. You select this row, which indicate, or you can, more easy to handle, just the shift and this arrow key. Okay, so this is the one we need to copy. Double click, it copied the formula. Okay, 100 multiply the random, this function, so random value. And here is the average. Okay. So now for the sample mean, we have 1,000 samples. Each sample have a mean. We have 1,000 mean. Okay. So we have 1,000 mean. That's the sample statistic. We like to know what's the distribution of this one. Okay. So what we can do, we certainly can create a histogram. Okay. So Excel also have the histogram here. Okay. See, this is the histogram. Oops. Yeah, just copy paste to a higher place. Yeah. To here. Okay. So this one is the put here. I can change it to see sample mean. And also we know the sample size equal to 35. So what I can do, I can go to Minitab. So this sample mean, I need to put the change to uniform 35. That's this is the uniform sample mean. Sample size is 35, so, and then I can generate the histogram here. That's much more. So that's why sometimes if you are processing the statistical graph, it's better using the statistics software. Although Excel can give you some, but so the frequency we can see. can change to interesting. Yeah, I like to see the type, yeah, to percentage. So this is the histogram. Yeah, if you use Mac, or if it's really hard for you to change the percentage, is okay. You can submit with just the frequency. That's okay. If it's really hard for you to change that. Okay. So I can remove this. So this is the histogram. So the sample distribution looks like a normal distribution, right? And also we can tell what's the sample mean. Okay. Or sample mean and sample standard deviation. So sample mean as the average of this one. Okay. So now we talk about this 1,000 statistic. Okay, the sample mean. We have 1,000 samples, so we know where is the standard average. Okay, the standard deviation, we just use standard deviation sample. So this is the sample standard deviation. So we look at the theoretically, the true population mean and the true population standard deviation. Population mean is 50, so 49.8 is very close. Population standard deviation 28.86, but my sample mean standard deviation is quite small. Okay. So the reason we learned the linear combination, we have how many? We have the sample size. Sample size is 35, right? So this one should be the theoretical statistic sample 28.86 divided by square root of sample size. Okay. Oops. No, 28. So you see this one, so it's quite close. So this sigma divided by square root of n. So that's because this is the average of 35 points from the same population. We learned the linear combination of random variables. The variance should be all these variance add together divided by 35. So the standard deviation will be this sigma divided by square root of 35. Are you with me? Okay, awesome, thank you. So this is I did in Minitab. Here we follow, yeah, we already run out of time. So if we sample size is 5, you see, the compare sample size 35, the variance is small, right? Sample size is 5, the variance is larger, okay? But the center both are 50. So this is called central limit theorem. No matter original population, for ours is this one, uniform distribution. So when the sample size is usually larger enough, larger than 30, the general shape becomes normal distribution. Okay. So now back to lab. So what we are going to verify, you need to provide the sample mean, okay, these two, and also the distribution. For the uniform, distribute 35, and then you need another one. Just you can use Minitab or use Excel. So at least one, like 35, you use Excel, so you know how to generate random variable using Excel. Okay. And then I ask you to generate 1,000 random sample of size 35 from binomial random variable. Okay. So binomial random variable, you use Minitab to generate, and then do the same thing to paste, copy paste the histogram and the statistic, the basic statistic, mean standard deviation, back to Excel. So this is binomial distribution. You have sample size is 35. So this one use Minitab. This one you can use Minitab or use Excel. Okay, next we are going to generate the random samples from the same uniform distribution, but only five values. So what we can do, we can just copy but we still need 1,000 sample. But this time, each sample, the size, only 5 value. Okay? So we can copy this part. That's easy to do. So you see the value are different because every time you have the operation in Excel, the random seed changed. So the values are different. So every time I select 5 data points from the same population, which is uniform distribution between 0 and 100. So next I calculate the sample mean. Okay? Sample mean is the average of these 5 values. You right click, it automatically copy the formula. See, you have 1,000. Now next we like to know the sample average and sample standard deviation. You can put here. So it's like directly copy the formula. So this is the sample average. Okay. Sample means average. And the sample mean standard deviation. Let's see, sample mean standard deviation. Okay, now we compare with the population. I can change it like population. Oops. So we can compare. See, here is the population. So still sample mean, although this time my sample size becomes smaller, only 5, but the sample mean still on the very close to population mean. Sample mean standard deviation. So I know this sample mean, how it varies. So it should be close based on the linear combination of your random variable. That's equal to the each individual value's standard deviation, which is 28.86, divided by square root of sample size. Here, my sample size is 5. See, this is quite close. Okay. So what's the shape? Does the shape also follow normal distribution if my sample size is small. So we can do, yeah, you also can just insert here is you can insert the chart. Because I like to, you see, it's automatically generate a chart, but it's around a row number 900. I like to bring it back to the beginning of the worksheet. So the title we need to change sample mean and the sample size equal to 5. So these two are a little hard to compare, see? Since we like to compare these two, so here sample mean, sample size, 35. We can copy both. This is 35, and yeah, we use Control Shift and this down key. So select exactly the data set. So it's better this way instead of select the whole column. So we generate a histogram. Multiple graph overlaid in the same graph. Let me see what does this look like. Okay, so this is one way to see, to compare the sample. This is about the sample means distribution, and we have the sample size different, right? But we conducted 1,000 experiments. We look at if sample size equal to 5, the variance is much larger. Sample size is larger, 35, the variance of this sample mean distribution becomes smaller. You can put here. This is a comparison. Okay. So next, the binomial distribution. So we generate 1,000 samples. Sample size is 35, and from binomial distribution, what we can do, we can use random data, generate random data, follow binomial distribution. Number of rows, how many rows? We want 1,000. And store in columns, we know that's column C, C3. That will be data. Yeah, we use this, how about C11 to 35 to C46. C45, yes. Okay. So number of trials, event probability 0.05. Oh, I didn't mention number of trials. So C, for example, number of trials is from 100. So we look at the data is here from C11. So to C 45. So the data follow binomial distribution. And then we want we need to use calculator. We use row statistics. So calculate every row. What's the statistics? Mean input is from C11 to C45. Store results here, sample mean. So we calculate each row, what's the mean from C11 to column 11 to column 45. So this is the mean. And then we can find out we call descriptive statistics. We know the sample mean is 1,000 sample means. This is also from the random variable, okay? Because every time this. So we like to see, so what's the data looks like? So we have 1,000 data. The average, the mean is 5. So for the binomial distribution, n equal to 100, p equal to 0.05. So the population mean equal to np. Okay. So that's equal to 5, that's correct. And then the standard deviation. So we can calculate the standard deviation. We bring this back to Excel. So this is, we generate, so the sample, the 1,000 row, and what's the mean and standard deviation. And the next, we want to know the shape of the sample mean distribution. So we use histogram. Remove the old one. It's not that good, but it's still sort of close to normal. But if we generate, say, 5,000, or if the sample size is larger, you will see it's close to normal. Looks like. And then we calculate population mean equal to 100, 0.05, and the population standard deviation. Population standard deviation, that's equal to square root np 1 minus p. N is 100, p we multiply 0.95, 1 minus p. So we look at here standard deviation. So we calculate the population standard deviation divided by square root of the sample. The sample size here, the sample size is 35. See, this one and this one is quite close, right? So it's like a verification of the sample mean, the standard deviation, and verification of the sample. Sample means mean, okay, equal to the population mean. Sample means standard deviation equal to the population divided by a square root of n. Okay, and the general shape. So it's, if we have the experiment instead of 1,000, you have more, it will have a better shape, should be follow normal distribution. So we can try. So this is not, now you're done with your Lab3. If you have generate this one from using Excel, and uniform 5, you can use Excel or a Minitab. Binomial distribution, you use Minitab. And then give out the final result. And then verify the standard deviation, the mean. Okay? And also you have the histograms. You're done with this one. Now I'm just curious, I can, because the shape didn't look that normal. So instead of generate 1,000, how about generate binomial distribution if I generate 5,000? And also we calculate the row statistics. Okay. So row statistics here. And then we display see the mean and the standard deviation. What's the shape? Does the shape looks better if I have 5,000 experiments, 5,000 samples? Yeah, it looks better, right? So compared to the previous one. So come back to the central limit theorem, tell us, no matter original population, what's the distribution? So we test the uniform distribution. It looks like this. But your sample mean distribution looks normal now. And some distribution is very weird. It's have two mode, right? This is exponential distribution. So once your sample size getting larger, usually if it's larger than 30, the sample mean will follow normal distribution. If it's normal distribution, the population is normal distribution, is always normal distribution no matter the sample size. Okay, so that's the Lab3.